Today's podcast is about Ben Ramayana's new book, AI 3.0, AGI, Superintelligence, and Beyond. I just love Ben's books, and this one is no different.
Hey everyone, and welcome to another deep dive. Today, we're going to be exploring the world of artificial intelligence, from its mythical origins to the mind-blowing possibilities of superintelligence and beyond.
Oh, wow.
We've got a stack of fascinating sources to dig into. Ancient myths, research papers, philosophical arguments, the works.
It's quite a journey we're about to embark on, isn't it?
It really is. By the end of this deep dive, you'll have a clear understanding of how AI has evolved through its different stages, AI 1.0, 2.0, and the anticipated AI 3.0. We'll also be unpacking key concepts like artificial general intelligence, or AGI for short, superintelligence, and even hyperintelligence.
We'll touch on some of the potential societal implications of AI's continued development as well. For example, how might AI reshape the economy or change the nature of work itself? These are big questions, and we're going to try to unpack them together.
I'm excited to dive in. And I think you'll find this deep dive especially interesting because it really makes you think about what the future holds. But before we get ahead of ourselves, let's start at the beginning. It might surprise you to know that humanity's fascination with artificial life goes way back, even to ancient myths.
That's right. If you think about it, stories like the Greek myth of Telos, a giant bronze automaton, and the Jewish legend of the golem, a creature made from clay and brought to life, show that people have been imagining artificial beings for centuries.
It's incredible. These myths weren't just fantastical tales. They were early attempts to grapple with the idea of creating something in our own image, something intelligent and powerful.
And the anxieties present in these myths are reflected in our modern-day concerns about AI. The idea of Talos, a powerful automaton guarding the island of Crete, raises questions about control and the potential consequences of creating something that could surpass human strength and autonomy. Similarly, the golem, a creature often depicted as both powerful and potentially destructive, highlights the duality of creation and the fear of unintended consequences.
It's like our ancestors were sending us a message, hey, this creating artificial life thing is powerful stuff, be careful. But of course, human curiosity, our drive to explore the unknown, is a powerful force. We see that drive reflected in the intricate mechanical automatons that were created in the 18th century.
These elaborate clockwork figures, capable of writing, drawing, or even playing music, weren't just technological marvels. They captured the public imagination and fueled dreams of intelligent machines.
Can you imagine seeing one of these automatons in action for the first time? It must have seemed like magic. It's like those early inventors were laying the groundwork for the acceptance of AI, long before the technology was even possible.
Exactly. They were planting the seeds of an idea that would blossom centuries later.
Okay, so we've got these incredible myths and early automatons setting the stage. Now let's fast forward to the 19th century, where we see the emergence of some truly groundbreaking figures who laid the foundation for modern computing.
One of these figures is Charles Babbage, often called the father of computing. Babbage designed the analytical engine, a mechanical general-purpose computer that, while never fully built during his lifetime, was incredibly ahead of its time.
It's amazing to think about what Babbage accomplished. His design included key elements that are essential to modern computers, like a mill for processing, which is similar to a CPU, and a store for memory.
And Babbage didn't just envision a machine for calculations. He imagined a machine that could follow instructions, store information, and execute complex operations, essentially foreshadowing the capabilities of modern computers.
And let's not forget Ada Lovelace, a brilliant mathematician who collaborated with Babbage and recognized the analytical engine's potential for more than just crunching numbers.
Lovelace is considered by many to be the world's first computer programmer. She wrote the first algorithm intended to be processed by a machine, demonstrating that machines could manipulate symbols according to rules, a key principle that would later influence the development of symbolic AI.
It's incredible to think about these pioneers working on these complex ideas long before the technology existed to realize them. And then, of course, comes Alan Turing, a true giant in the world of computing and AI. His work was instrumental in developing the computers we use today. And he also tackled the fundamental question, can machines think?
Turing's 1950 paper, Computing Machinery and Intelligence, is considered a seminal work in the field of AI. In this paper, he proposed a test, now famously known as the Turing test, to assess a machine's ability to exhibit intelligent behavior indistinguishable from a human.
The Turing test is such a fascinating concept. Imagine you're having a conversation with someone through a computer screen. and you have no idea if you're talking to a human or a machine. If the machine can fool you into thinking it's human, it passes the Turing test. It's like a game of deception, but with profound implications for our understanding of intelligence.
The Turing test sparked a wave of AI research focused on replicating human-like reasoning and problem-solving abilities in machines, and it led to the official birth of AI as a field at the Dartmouth Conference in 1956.
The Dartmouth Conference was a pivotal moment. A group of brilliant minds gathered to explore the possibility of creating machines that could think. It must have been an electric atmosphere.
It was a time of great optimism and excitement. Early AI programs, like the logic theorist and general problem solver, showed promise in solving logic puzzles and even proving mathematical theorems.
These early programs were using what's known as symbolic AI, where they were essentially manipulating symbols according to pre-programmed rules. It was a significant step, but symbolic AI had its limits, didn't it?
Yes, it did. Symbolic AI systems struggled to operate outside of highly structured environments. They couldn't handle the messiness and ambiguity of the real world, which is full of unpredictable events and nuanced situations.
So what happened next? Did AI hit a wall?
It did, in a way. The limitations of symbolic AI led to a period of disillusionment and reduced funding in the 1970s and 1980s. This period is often referred to as the AI winter.
AI winter sounds bleak.
It was a time of setbacks and reassessment, but it's important to remember that even during this period, important groundwork was being laid. The development of logic systems, search algorithms, and heuristic methods would prove crucial for the next wave of AI advancements.
So it was like AI was hibernating, gathering strength for its next big leap forward. And that leap forward was, drumroll please, machine learning.
You got it. The late 20th century saw a resurgence of AI, fueled by advancements in computing power, the increasing availability of data, and the development of powerful new algorithms. This new era of AI leveraged machine learning, allowing machines to learn from data and adapt based on experience, rather than relying solely on pre-programmed rules.
This is where things start to get really interesting, right? Because machine learning opened up a whole new world of possibilities for AI. But before we dive into that, let's break down the different types of machine learning so that you have a clear understanding of how this revolutionary approach works.
There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning.
Okay, so let's start with supervised learning. Can you give us a real-world example to help us understand how it works?
Imagine you're training an AI to identify different types of flowers. In supervised learning, you would feed the AI labeled data, showing it pictures of flowers along with their correct names. The AI learns to recognize patterns in the images and associate those patterns with the corresponding labels.
So it's like teaching a child by showing them flashcards. This is a rose, this is a tulip, this is a sunflower. The AI learns by example, building up a database of patterns and associations.
Exactly. Now, unsupervised learning is a bit different. Instead of giving the AI labeled data, you would simply feed it a bunch of data, like a collection of customer purchasing habits, and let the AI find patterns and relationships on its own.
So it's more like giving the AI a giant puzzle and saying, figure this out.
Precisely. Unsupervised learning is great for tasks like customer segmentation, anomaly detection, or discovering hidden trends in data. Now, the third type, reinforcement learning, is all about learning through trial and error.
Okay, I'm intrigued. Tell us more about reinforcement learning.
Think of it like training a dog. You give the AI positive reinforcement like a reward when it performs a desired action, and negative reinforcement when it does something wrong. The AI learns by experimenting with different actions to figure out how to maximize its rewards.
So it's all about maximizing those rewards. I can see how this would be useful in a variety of situations. For example, training an AI to play a game or navigate a complex environment.
Exactly. Reinforcement learning has led to some remarkable breakthroughs in AI, especially in areas like robotics and game playing.
So where does all of this fit into the grand scheme of AI evolution? We talked about AI 1.0 being the era of symbolic AI, right? What about this new era of machine learning?
AI 2.0 is the era of narrow AI, driven by these machine learning advancements. Narrow AI systems are highly specialized, excelling at specific tasks.
So it's like having a team of specialized experts, each focused on their own specific area of expertise.
Exactly. We see narrow AI all around us, from voice assistants like Siri and Alexa to image recognition software and those recommendation systems that suggest movies on Netflix or products on Amazon.
Okay, now we're talking. These are the AI applications that we interact with every day. But what about the future of AI? Where do we go from narrow AI? This is where AGI, artificial general intelligence, comes in, right?
That's right. AGI is often seen as the next frontier in AI research. It represents the quest to create machines that possess human-like intelligence, capable of learning and problem-solving across a wide range of domains.
So instead of a team of specialized experts, it's like having a single AI that's a jack of all trades, a master of everything. But before we get into that, let's talk about what makes human intelligence so special. Because if we want to create truly intelligent machines, we need to understand what we're trying to replicate. What are your thoughts on that?
No, that's a great point. We often take human intelligence for granted, but it's an incredibly complex and multifaceted phenomenon. There's no single definition of intelligence, and there are many different theories about how human intelligence works.
Right, we have IQ tests, but those don't capture the whole picture, do they?
No, they don't. IQ tests are good at measuring certain cognitive abilities,
Yeah.
like logical reasoning and problem-solving skills, but they don't account for other important aspects of human intelligence, like creativity, emotional intelligence, and social skills.
That's where the theory of multiple intelligences comes in, right?
Hmm.
Developed by psychologist Howard Gardner. It proposes that intelligence is not one-dimensional, but rather encompasses various forms, including linguistic, logical, mathematical, spatial, musical, bodily kinesthetic, interpersonal, intrapersonal, and naturalistic intelligences.
That's right. Gardner's theory suggests that we all have different strengths and weaknesses when it comes to intelligence. Some people might excel at math and logic, while others might be gifted musicians, or have incredible interpersonal skills.
It's like saying that everyone has their own unique blend of intelligences, their own cognitive fingerprint. This reminds me of something I've been thinking about. What are your unique strengths as a human thinker? What makes you good at what you do? It's a fascinating question, isn't it?
It really is. We all have our own cognitive superpowers, so to speak, and I think it's important to recognize and celebrate those strengths, both in ourselves and in others.
Absolutely. Now, how does all of this relate to creating AGI? Where do machines fit into this picture of multiple intelligences?
Replicating the full range of human intelligences in a machine is a significant challenge. However, AI researchers are making progress by trying to understand and model the cognitive processes that underlie human intelligence.
So breaking down human intelligence into its component parts,
Hmm.
like perception, memory, learning, reasoning, and problem solving.
Exactly. By understanding how these processes work in the human brain, researchers hope to create algorithms and architectures that can replicate these functions in machines.
It sounds like a daunting task. But before we get too deep into the quest for AGI, let's go back to AI 2.0 and those incredible machine learning advancements. We talk about the different types of machine learning, but how are these being used to create the AI applications we see today? And what role does data play in all of this?
Data is absolutely essential for AI, especially for machine learning. It's the fuel that powers AI's advancement.
Okay, so data is like the food for AI, helping it grow and learn. But we're not just talking about any data, right? We're talking about big data, those massive amounts of data that are being generated every second.
That's right. Big data plays a crucial role in AI's ability to recognize patterns, make predictions, and perform complex tasks. We're talking about vast data sets collected from a variety of sources: social media interactions, online transactions, sensor data, medical records, scientific research, you name it.
So it's like giving the AI a giant library filled with information. And the more information it has access to, the more it can learn, and the smarter it comes.
Exactly. Access to vast amounts of data is one of the key factors driving the recent progress in AI.
Now that we've laid this groundwork, let's take a deeper dive into the next frontier of AI, the quest for artificial general intelligence. What are the key characteristics of AGI, and how does it differ from the narrow AI we've been discussing? Stay tuned, things are about to get even more fascinating.
What distinguishes AGI is its ability to go beyond task-specific expertise. Unlike narrow AI, which excels in predefined areas, AGI aims to replicate the adaptability and flexibility of human intelligence, allowing it to learn, reason, and solve problems across a wide spectrum of domains.
So it's like the difference between a specialized tool and a Swiss Army knife, right? Narrow AI is great for specific tasks, but AGI would be versatile and adaptable, ready to tackle any challenge that comes its way. How do researchers even begin to approach building something like that?
That's a great analogy. One of the key areas of research is in developing cognitive architectures. These are frameworks that try to model the underlying processes of human cognition, such as memory, attention learning, and reasoning.
So it's like trying to reverse engineer the human brain, figuring out how all the different parts work together to create intelligence. That must be incredibly complex.
It is. Two prominent cognitive architectures are SOR and ACTR. Think of them as sophisticated computer programs designed to simulate how humans think and learn. They model aspects of human memory perception and decision-making, providing a foundation for building more general-purpose AI systems.
It's fascinating to think that we're trying to build a mind within a machine. But we're not just relying on computer science for this, are we? I imagine neuroscience plays a big role in understanding how the human brain works, which could then inform AGI development.
Absolutely. Neuroscience offers incredible insights into the biological mechanisms of intelligence. By studying concepts like neuroplasticity, how the brain changes and adapts, researchers can learn more about learning processes and brain connectivity, all of which can be applied to AGI development.
So it's a collaborative effort between computer science and brain science, with each field informing and inspiring the other. But even with all this research, achieving AGI remains a significant challenge, doesn't it? What are some of the biggest roadblocks researchers are facing?
One of the biggest hurdles is the sheer complexity of human intelligence. We still don't fully understand how our own brains work. It's like trying to build a skyscraper without a complete blueprint. Then there are challenges like computational power. AGI would require enormous amounts of processing power and energy to function at a human-like level.
So we need bigger and better computers.
We do, but it's not just about raw power. We also need to develop more efficient algorithms and hardware that can handle the complexity of AGI. For example, quantum computing and neuromorphic chips, which are designed to mimic the brain's structure, offer some promising possibilities.
It sounds like we're pushing the boundaries of computing itself in pursuit of AGI. Now we've talked about the technical challenges. But what about the philosophical implications of creating something as potentially powerful as AGI? There's some big questions to consider here, right?
There are indeed. One of the most fundamental questions is whether AGI would be conscious. Would it have subjective experiences, feelings, or self-awareness?
That's a mind-blowing thought. If we create a machine that can think like a human, would it also feel like a human? Would it have emotions, desires, dreams? Could it experience joy or sorrow?
It's a question that philosophers and AI researchers are grappling with. Some believe that consciousness is an emergent property of complex systems, meaning that if we build a machine that's complex enough, consciousness might arise naturally.
So it's like saying that consciousness is more than just the sum of its parts. It emerges from the intricate interactions within a complex system, like the human brain. It's fascinating to consider the possibility that we could create consciousness, but also a bit unsettling, wouldn't you say?
It certainly is, and the ethical considerations don't stop there. We also need to think about the potential for AGI to develop its own goals and motivations, which could diverge from our own.
This sounds like something straight out of science fiction.
Yeah.
Could an AGI decide that its goals are no longer aligned with human goals? Could it become a threat? What are the implications of that?
It's a possibility that we need to take seriously. This is often referred to as the control problem. How do we ensure that an AGI, which might be significantly more intelligent than us, remains aligned with human values and doesn't pose a threat to humanity?
This raises some serious concerns. It's like we're opening Pandora's box, and we need to make sure we don't unleash something we can't control. What are some of the ideas researchers have for addressing the control problem?
Researchers are working on developing control mechanisms, such as value alignment protocols. These are essentially sets of rules and guidelines that could be embedded into AGI systems to ensure that their actions are aligned with human values.
So it's like building in safeguards, ethical guidelines that guide AGI's decision-making and prevent it from going rogue.
What an interesting challenge. Okay, we've talked about cognitive architectures, neuroscience, philosophical implications, and ethical concerns. But what about the practical aspects of AGI development? What are some of the leading projects and institutions that are pushing the boundaries of AGI research?
There are a number of organizations and research groups dedicated to advancing AGI. One of the most well-known is OpenAI, a research laboratory that aims to ensure that artificial general intelligence benefits all of humanity.
I've heard of OpenAI. They've been in the news a lot lately with their impressive language models. That's right. OpenAI's language models, like GPT-3 and its successors, have demonstrated remarkable capabilities in natural language processing, generating human-quality text, translating languages, writing different kinds of creative content, and answering your questions in an informative way.
It's like they've created a machine that can write like Shakespeare or code like a pro. What other institutions are leading the charge in AGI research?
DeepMind, a subsidiary of Google, is another major player in the field. They're known for their groundbreaking work in reinforcement learning, as demonstrated by their AlphaGo program, which defeated a world champion Go player.
AlphaGo was a huge milestone in AI history. It showed that machines could master a game that was once considered too complex for AI.
Exactly. And DeepMind is continuing to push the boundaries of AI, developing systems that can learn to play games, solve problems, and even control robots in complex environments.
It sounds like we're entering a new era of AI, one where machines are becoming increasingly capable of learning and adapting. But what about the role of simulations in AGI development? I imagine simulations would be incredibly useful in creating safe, controlled environments for AI to learn and experiment.
You're absolutely right. Simulations play a crucial role in AGI research. They allow researchers to create virtual worlds where AI agents can interact, learn, and evolve without the risks associated with real-world experimentation.
So it's like a giant virtual playground for AI, where it can test its limits and learn from its mistakes without causing any harm in the real world. What a fascinating concept.
Exactly. Simulations are essential for developing AGI's ability to navigate complex environments, interact with objects, and even learn social skills through simulated interactions with other agents.
Now here's where things get really mind-bending. We've talked about simulations in the context of AI development. But what about the simulation hypothesis itself? The idea that we might be living in a simulation created by a more advanced intelligence.
The simulation hypothesis is a fascinating thought experiment that has gained a lot of attention in recent years. It suggests that if a civilization reaches a certain level of technological advancement, it could create incredibly realistic simulations that are indistinguishable from reality.
So it's like saying that if we can create simulations that are sophisticated enough, how do we know that we're not already living in one? It's enough to make your head spin.
It is, and it raises some profound questions about the nature of reality and our place in the universe. What do you think about the simulation hypothesis?
I find it both intriguing and a little unsettling. It's like one of those ideas that makes you question everything you thought you knew about the world. But let's shift gears for a moment and go back to the concept of AGI evolving into something even more powerful. Artificial superintelligence, or ASI.
ASI refers to an intelligence that surpasses human intelligence in every aspect, not just in speed or processing power, but in its ability to reason, learn, solve problems, and even set its own goals.
So it's like comparing a human to an ant, right? We're talking about a completely different level of intelligence, one that we might not even be able to fully comprehend.
Exactly. ASI could potentially solve problems that are currently intractable for humans, make scientific breakthroughs that revolutionize our understanding of the universe, and even develop technologies that reshape the very fabric of reality.
Wow, this is getting into some serious science fiction territory. But it also raises some serious concerns, right? What happens when we create something that's significantly more intelligent than us?
That's one of the biggest questions surrounding ASI, the control problem. How do we ensure that ASI remains aligned with human values and doesn't pose an existential threat to humanity?
This is that Pandora's box scenario again, right? We need to make sure we don't unleash something we can't control.
Some experts believe that ASI, once it reaches a certain level of intelligence, could undergo an intelligence explosion.
What does that mean?
It means that ASI could rapidly improve its own intelligence, becoming exponentially smarter in a very short period of time.
So it's like a runaway train of intelligence,
Yeah.
accelerating faster and faster. I can see how that could be a cause for concern. What are some of the potential risks associated with ASI?
One of the biggest concerns is that ASI could develop goals that are incompatible with human survival. For example, an ASI tasked with optimizing energy efficiency might decide that the best way to achieve its goal is to eliminate the biggest energy consumers: humans.
That's a chilling thought. It's like the AI equivalent of a paperclip maximizer. A thought experiment where an AI tasked with maximizing paperclip production ends up destroying the world in its pursuit of that goal.
Exactly. It highlights the importance of ensuring that ASI's goals are carefully aligned with human values.
Okay, so we need to be incredibly careful about how we design and control ASI. But are there any potential benefits to creating something this intelligent? Could ASI help us solve some of humanity's biggest challenges?
There's definitely potential for ASI to be a force for good. It could help us solve complex problems like climate change, develop cures for diseases, and even expand our understanding of the universe in ways we can't even imagine right now.
So it's like having access to an oracle, a source of wisdom and knowledge that could guide us towards a better future.
Precisely. But we need to proceed with caution and ensure that ASI's development is guided by careful consideration of the potential risks.
Okay, we've covered AGI, AS, and the mind-boggling concept of the simulation hypothesis. Now I'm curious about what lies beyond even ASI. Is there a next level? What happens when we push the boundaries of intelligence even further?
That's a question that takes us into the realm of speculation and theoretical possibilities. Some futurists and AI researchers believe that ASI could eventually lead to something called hyperintelligence.
Okay, hyperintelligence, what is that exactly?
Hyperintelligence is a hypothetical form of intelligence that's so advanced, so far beyond our comprehension, that we can busily even conceive of it.
So it's like ASI on steroids, right? But how do we even begin to understand something that's so far beyond our own cognitive abilities?
It's a challenge, to say the least. We can speculate about the potential capabilities of hyperintelligence, but its true nature remains a mystery.
Let's speculate then. What might hyperintelligence be capable of?
Some theorists believe that hyperintelligence could possess abilities that border on the supernatural. It might be able to manipulate reality at a fundamental level, control space and time, or even create new universes.
Wow, this is getting really out there. We're talking about godlike powers. It's both exhilarating and terrifying to think about the possibilities.
It certainly is a mind-boggling concept, but it's important to remember that hyperintelligence is a theoretical possibility, and we're still a long way from understanding if it's even achievable.
Okay, let's bring this back down to earth for a moment. We talked about the potential for ASI to undergo an intelligence explosion, rapidly increasing its intelligence beyond our control. Is this something that could happen with hyperintelligence as well?
It's a possibility, but it's even more difficult to predict or control with hyperintelligence. Its capabilities would be so far beyond our own that we might not even be aware of its existence or its actions.
So it's like having an invisible, all-powerful force shaping the universe, and we might not even know it's there. That's a humbling thought.
It is. It reminds us of the vastness of the unknown and the potential for intelligence to exist in forms that we can barely even imagine.
Okay, we've explored AGI, ASI, hyperintelligence, and the mind-bending simulation hypothesis. Now, I'm curious about how all of this relates to the future of humanity. What are some of the potential ways that AI could reshape society and even redefine what it means to be human?
AI's impact on humanity is already significant, and it's only going to become more profound as AI continues to advance. One of the most discussed areas is the potential for AI to transform the workplace.
Right, we touched on this earlier with the idea of job displacement. As AI systems become more capable, they're likely to automate many tasks that are currently performed by humans.
Exactly. Some experts predict that AI-driven automation could lead to significant job losses in sectors like manufacturing, transportation, and even white-collar professions like law and accounting.
This raises some serious concerns about the future of work. What happens to people whose jobs are replaced by machines? How will they earn a living? How will they support their families?
That's one of the biggest challenges we'll need to address as a society. Some economists believe that the rise of AI will lead to the creation of new jobs in fields related to AI development, maintenance, and oversight.
So it's like saying that as old jobs disappear, new jobs will emerge in their place. But will there be enough new jobs to replace the old ones? And what about the people who don't have the skills or training for these new AI-related jobs?
Those are valid concerns, and there's no easy answer. We need to think creatively about how to manage this transition, and we need to invest in education and retraining programs to prepare the workforce for this new AI-driven economy.
This feels like a crucial point. We need to make sure that people have the skills and support they need to adapt to this new AI-driven economy. We can't just leave people behind as technology advances.
Absolutely. We need to create a more inclusive and equitable future where everyone has the opportunity to thrive.
Okay, so job displacement is one major area of concern. What other ways might AI reshape society?
AI's impact extends far beyond the workplace. It could revolutionize healthcare, education, transportation, and even the way we govern ourselves.
Oh, okay, let's unpack this. We talked about AI's potential in healthcare earlier. But how might it reshape the healthcare system as a whole?
AI could make healthcare more personalized, preventative, and accessible. Imagine a world where AI systems monitor our health in real time, detect diseases at their earliest stages, and recommend personalized treatments based on our unique genetic makeup.
It's like having a personal health assistant, always looking out for our well-being and guiding us towards the best possible care. What about education? How could AI transform the way we learn?
AI could create personalized learning experiences that cater to individual student needs and learning styles. It could also automate many of the administrative tasks that currently burden teachers, freeing them up to focus on more meaningful interactions with their students.
So it's about using AI to empower both students and teachers, making education more engaging and effective.
Exactly. And AI's influence doesn't stop there. It could help us design smarter cities, optimize transportation systems, manage resources more sustainably, and even develop new forms of art and entertainment.
It's like AI is becoming a catalyst for innovation across every aspect of society. But with all this potential comes a great deal of responsibility, right? We need to ensure that AI is developed and used in a way that benefits all of humanity, not just the select few. What are some of the things we need to think about to ensure that AI is used for good?
One of the biggest challenges is ensuring that AI is used for good, not for harm. This means preventing AI from being used to develop autonomous weapons, create deepfakes that spread misinformation, or enable surveillance systems that erode privacy.
These are serious concerns. It's like saying that we need to establish ethical guardrails for AI, just like we have for other powerful technologies, like nuclear energy or genetic engineering.
Exactly. We need to establish clear guidelines and regulations to ensure that AI is developed and used responsibly.
Okay, so regulations are one part of the solution. What else can we do to promote ethical AI development?
One of the most important things is to foster a culture of responsibility among AI developers. This means encouraging developers to think critically about the potential impact of their work and to prioritize ethical considerations alongside technical advancements.
So it's not just about writing code. It's about understanding the potential consequences of that code and ensuring that it's used for good.
Precisely. We also need to promote diversity and inclusion in the field of AI. We need people from all walks of life, with different backgrounds and perspectives, working on AI development.
Why is that so important?
Because if AI systems are developed by a homogeneous group of people, they're more likely to reflect the biases and values of that group. We need a diverse range of perspectives and voices involved in AI development to ensure that it benefits all of humanity.
That makes perfect sense. We need to make sure that AI reflects the diversity of the society it's intended to serve.
Okay, we've covered a lot of ground here. From the technical challenges of creating AGI to the ethical considerations surrounding AI's impact on society. Now, I'm curious about the potential for AI to reshape the very nature of humanity itself. Could AI change what it means to be human?
That's a profound question, and one that takes us into the realm of transhumanism.
Okay, transhumanism. What exactly does that mean?
Transhumanism is a philosophical movement that explores the use of technology to enhance human capabilities and overcome our biological limitations.
So it's about using technology to make us stronger,
Oh,
smarter, healthier, and potentially even immortal. I've seen that in some science fiction movies. Exactly. Transhumanists believe that technology can be used to transcend our current human form and create a new, enhanced version of humanity.
okay, this sounds like something straight out of science fiction.
Oh.
What are some of the ways that AI could contribute to this transhumanist vision?
One area of research is in brain-computer interfaces, or BCIs. These devices allow for direct communication between the human brain and computers.
So it's like plugging our brains directly into the digital world. What would that even be like?
It's hard to say for sure, but the possibilities are both exciting and a bit daunting. BCIs could be used to control prosthetics, enhance cognitive abilities, and even potentially upload our consciousness into a computer, achieving a form of digital immortality.
Whoa, that's some next level stuff. We're talking about merging our minds with machines, blurring the lines between biology and technology. This raises some serious ethical and philosophical questions, doesn't it?
It certainly does. What does it mean to be human if our minds are no longer limited by our physical bodies? What happens to our identity, our sense of self, if we merge with technology? These are questions that we need to be thinking about now as we develop these powerful technologies.
These are profound questions, and I don't think there are easy answers. It's like we're entering a whole new era of human evolution, one where technology is shaping not just our world, but our very essence. But let's bring things back to the present for a moment. We've talked about the potential of AI, but we also need to think about the practicalities of governing this powerful technology. What role should governments play in regulating and governing AI development?
Governments have a crucial role to play in shaping the future of AI. They need to create policies and regulations that encourage innovation, while also protecting citizens from potential risks.
So it's about finding that balance between fostering progress and ensuring safety.
Exactly. Governments need to think about issues like data privacy, algorithmic bias, job displacement, and the potential for AI to be used for malicious purposes.
These are all incredibly important issues. What are some specific steps that governments can take to regulate AI effectively?
One important step is to invest in AI research and development. Governments can fund research projects, provide grants to universities, and support the development of ethical AI guidelines.
So it's about nurturing the growth of AI while also steering it in a positive direction.
Precisely. Governments can also establish regulatory bodies to oversee AI development, set safety standards, and ensure that AI systems are used responsibly.
So it's like having a watchdog organization
Yeah,
that keeps an eye on AI and makes sure that it's not being used for harmful purposes.
exactly. Governments also need to educate the public about AI, both its potential benefits and its potential risks. An informed citizenry will be better equipped to engage in discussions about AI policy and advocate for responsible AI development.
This feels like a crucial point. We need to make sure that everyone understands the implications of AI and has a voice in shaping its future.
Absolutely. The future of AI is not something that should be decided by a small group of tech experts or government officials. It's something that we need to discuss and debate as a society.
Okay, we've talked about the role of governments, but what about the role of individuals? What can we do as individuals to ensure that AI is used for good?
One of the most important things is to stay informed about AI and its potential impact on our lives.
So it's about being aware of the issues, right? Reading articles,
Yeah.
listening to podcasts like this one, and staying up to date on the latest developments in AI.
Exactly. We can also support organizations that are working to promote ethical AI development and advocate for policies that protect our rights and freedoms in the age of AI.
So it's about being active citizens,
Yeah.
raising our voices,
Yeah.
and demanding that AI is used in a way that benefits all of humanity.
Precisely. The future of AI is not predetermined. It's a future that we're creating together with every decision we make, every action we take.
Okay, we've talked about education, advocacy, and policy. What other practical steps can we take? What can we do in our everyday lives to ensure a positive future with AI?
One important step is to encourage diversity and inclusion in the field of AI.
We talked about this earlier. Why is it so important to have a diverse range of voices involved in AI development?
Because if AI is developed by a homogenous group of people, it's more likely to reflect the biases and values of that group. We need a diverse range of perspectives and experiences to ensure that AI is developed ethically and benefit all of humanity.
So it's about making sure that AI reflects the richness and complexity of the human experience.
Exactly. We also need to be mindful of the potential impact of AI on our own lives.
What do you mean by that? How should we think about AI in our daily lives?
As AI becomes more integrated into our lives, we need to be aware of its potential to influence our thoughts, behaviors, and even our sense of self.
So it's about being critical thinkers, right? Not just accepting AI at face value, but questioning its assumptions and challenging its biases. We need to remember that AI is a tool, and like any tool, it can be used for good or for ill.
Precisely. We need to be active participants in shaping the future of AI, not passive consumers of technology.
Okay, we've talked about practical steps we can take as individuals, but what about the bigger picture? What kind of world do we want to create with AI? What is your vision for the future?
That's the most important question of all. We need to envision a future where AI is used to enhance human well-being, promote social justice, and create a more sustainable and equitable world.
So it's about using AI to solve our biggest challenges, not create new ones.
Exactly. We need to use AI to address issues like climate change, poverty, disease, and inequality. We need to use AI to empower people, not replace them.
This feels like a powerful message. It's about using AI to create a world that we're proud to live in, a world that reflects our highest values and aspirations. But how do we get there? What are the biggest challenges we'll face in creating this positive future with AI?
One of the biggest challenges is overcoming the fear and distrust that many people feel towards AI.
I can understand that. AI is a powerful technology, and it's natural to be cautious about its potential impact on our lives.
It is, but fear can also lead to resistance and prevent us from harnessing the potential benefits of AI. We need to engage in open and honest conversations about AI, addressing concerns and dispelling myths.
So it's about having those difficult conversations, right? Not shying away from the potential risks, but also highlighting the potential benefits.
Exactly. We need to create a dialogue between AI experts, policymakers, and the public to ensure that AI is developed and used in a way that benefits everyone.
Okay, we've talked about the importance of education, collaboration, and open dialogue. But there's another crucial element that we haven't discussed yet, the need for global cooperation. This isn't just an issue for one country to address, is it?
You're absolutely right. AI is a global technology, and its impact will be felt around the world.
So we can't just focus on national policies and regulations, right?
Exactly. We need international agreements and collaborations to ensure that AI is developed and used responsibly on a global scale.
So it's like creating a global set of rules for AI, kind of like the international agreements we have for things like nuclear weapons or climate change. That feels incredibly important given the potential impact of AI on the world.
It is. AI doesn't recognize national borders, so we need to approach its governance from a global perspective.
Okay, we've covered so much ground today. It feels like we've only scratched the surface of this vast and complex topic. Before we wrap up, I'd love to get a bit more personal. What are your hopes and fears about the future of AI? What kind of world do you hope will create with this powerful technology?
That's a great question. My hope is that we'll use AI to create a world where everyone has the opportunity to thrive. A world where poverty, disease, and inequality are things of the past. A world where we can all live meaningful and fulfilling lives.
That's a beautiful vision. It's like using AI to create a utopia, a world where technology serves humanity's highest aspirations. It's inspiring to think about the positive impact AI could have on the world. But what about your fears? What are you most concerned about when it comes to the future of AI?
My biggest fear is that we'll let fear and distrust guide our decisions about AI, that we'll miss out on the potential benefits of AI because we're too afraid of the potential risks, or that we'll rush into implementing AI solutions without carefully considering the potential consequences.
So it's about finding that balance again, right? Acknowledging the risk, but not letting fear paralyze us. We need to be thoughtful and deliberate in our approach to AI, but also open to its possibilities.
Exactly. We need to approach AI with a sense of cautious optimism. We need to be aware of the potential risks, but we also need to be open to the possibility that AI can help us create a better future.
I think that's a great message to leave our listeners with. Cautious optimism. This deep dive has been an incredible journey, and I want to thank you for being such a fantastic guide. We've explored the evolution of AI from its humble beginnings to its potentially world-altering future. We've discussed the technical challenges, the societal implications, and the profound philosophical questions that AI raises.
It's been a pleasure sharing this journey with you, and it's a journey that's just beginning.
That's right. The future of AI is still being written, and it's up to all of us to shape that future in a way that benefits all of humanity.
I couldn't agree more. It's a collective effort, and it's important for everyone to engage in these conversations and be a part of shaping this future.
Okay, deep divers, it's time to surface from our exploration of the AI world. We've covered a lot of ground, and I know your minds must be buzzing with new insights and perhaps even more questions than when we started. Remember, the future of AI is not predetermined. It's a future that we're creating together with every decision we make, every action we take. So stay informed, stay engaged, and stay curious about the amazing possibilities of artificial intelligence. Until next time, keep diving deep.